Hi there. um, I'm now going to check the preload of the carrier bearings here. I haven't got the clutch packs in here at all. All I've done is that I want to check that the preload is okay. Although this is just a standard setup, I haven't adjusted the preload at all. All I've done is put new bearings in here, and obviously the seals. To check the preload, because I haven't got the clutch pack in here, I can only check it with the using the viscous coupling here on this side. So what I'll do now is I'll put the output shaft into the. This is where the viscous coupling is, and check that what the preload should be. The figure will be slightly less because I haven't got the output shaft on this side, because obviously there's going to be a frictional drag on the seal as well. So the figure that's going to come off here is going to be slightly less than the spec. So I'm just going to try it now and see what we've got. Okay. And we're running at about 1 Newton meter, or just 10 inch pounds. Do the other way. Yeah, just over 10 and just over 1. When we're not looking at the breakaway torque, it's the actual running torque we're looking for. So what have we got here? Yeah, about 10 and a bit. Now the spec I've got, carrier preload, which I've got off the internet. Now I don't know if these are right or wrong, so you're going to have to do your own research. Don't go on what these figures I'm telling you, but according to what the internet says, the carrier preload should be 1.02 to 1.24 Newton meters, or 9 to 11 inch pounds. Now that's without the seals. With the seal, it should be 1.24 to 2.60, or 11 to 23 inch pounds. Now, with the seals, apparently it's the frictional force is approximately 0.20 Newton meters. So at the moment we've only got one. As it's got the seal, it should be 1.24 to 2.60. This is with the seal, Newton meters. Now obviously I haven't got the output flange on here, so there'll be additional drag. So what have we got now? We're running at, what are we running at now? We're running it at just about one Newton meters, or 10 inch pounds. So if it had the other seal output shaft on the seal, the drag on the other seal would give it probably 1 point and a bit, 1.2 probably. So I'm happy with that, simply because I haven't messed with the preload. I just wanted to check what the preload is, just out of interest. I've already checked this before doing this video, but I did make a mistake putting the bearings in on here, and I'll show you what I did on the next video, because I put this in and I checked the preload, and it was absolutely solid. Well, not solid, but it was reading it was reading about, I think about 8 Newton meters, 0.8 Newton meters. So that wasn't definitely not right. So I took it all apart and I found out what the fault I did. And I'll show you on that on the next video. But just to give you an idea, see how it's virtually spot on that really. If I take the shaft out, you know, it's got a bit of resistance, but it's not heavily resistant. And I dare say when this when this is run in and the bearings have bedded in, it'll probably drop down to it might drop down to maybe 1 Newton meter when it's running. So I'm happy with that. I haven't touched any of the preload shims. I haven't done it. It's just bog standard as it came out of the factory. The only thing I've changed is the bearings. But I just hope that's information for anybody who's rebuilding a diff. But as I said, go and find your own figures, because I don't know if the figures I'm giving you are correct or wrong. I don't know. It's just what I've found on the internet. So anyway, I hope that's of use to you. Thanks. Bye.